Hi everyone, I would like to take you all through my collab notebook about the Instacart market basket analysis that I have done without using the a priori algorithm, which is the conventional method of doing market basket analysis to find out the association rule mining. However, I have done it manually, so let's go through and see how I have approached the method. So first thing is, as you can see from my screen, importing the pandas necessary libraries here, and I've mounted up on my Google Drive in which I have uploaded my data sets, and then reading the data files from using the pd.read method, and just making sure everything has been loaded correctly. I have the IELTS and the orders data file in which I have the order ID and the product, the hour of the day, etc., user ID, etc. And about the file which I am interested most is the df main data set, which has the product ID and the order ID. So these two are important in doing our analysis. So this will be our main data set for this analysis. So have done a couple of categorization on this data frame to summarize the orders, I'm skipping those things for now, and I'm going directly to the association rule mining part, which I have approached manually. So if you know the data set of Instacat, it is a data file which contains more than 32 million rows and 49,677 different products. So when I was doing that in using a priori algorithm, my computer was not able to handle it, and it was breaking a couple of times, and the kernel was dying. So I was not able to do that. So that's what drove me to do this using manually. And like I have explained in my the LinkedIn article. So going to do that manually by step. And um, for that I have made a first I have made a subset of 5,000 rows. I don't want to apply each and every step to test whether I'm right or not on the complete data set as such, because it would, for each step I'll be taking a lot of time to process the codes on all the data set, which has 32 million rows. But let me make a subset so that of so that I can get quicker results. Then if everything goes well, I'll apply everything at once to the data set and see how how the results uh, to see the results later. So first, I'm making a subset. I'm taking only the product order ID and product ID. Those are the fields I'm interested in to do this analysis for now. And I'm taking only 5,000 rows from the entire 32 million data set, so that I get this data set here, which has 5,000 rows and 2 columns. So if you look at the unique orders in it, I have only 499 orders, which has, out of the 5,000 rows, I have only 2,809 unique products in it. So if you look at the counts of each product, so this product with the ID, which is 24852, has occurred 70 times in the data set. So this actually the number of times this product has been bought out of the 5,000, the first 5,000 rows. So so now I know that the total number of orders in it, and the 70 out of 499, it actually gives the frequency of the product in this data set, in the subset. So um, divided by the unique orders, which is 499, I'll get the percentage of times it has been occurred in this data set. So this product has been occurred 14% of the times out of the 5,000 rows, and I get the same results for all the 2,809 products here. So I'm not interested in the complete products, because I need to somehow reduce the products so that I get more precise results. So let me check what is the minimum and maximum frequency that from this file. So the maximum is 0.14 as you can see here, and the bottom is 0.002. So this so I'm not interested in anything that below zero point zero 0.01 support, because that these products doesn't make any sense in the final results, because I'm looking at only the major products which causes which repeats in the data set. So let me fix this is just an assumption, but let me fix a minimum support so that I can get minimum. I don't want all the results. So I have filtered this data frame with a minimum support value of 0.01, so that I'll get only those products which has a minimum support of 0.01 or and above. So yeah, so out of this is the original data set, but if I apply this filter of only those products which has a minimum support of above zero point zero 0.01, I can reduce those data frame to contain only 1429 rows, which is which is on which is considerably low than the original the subset. So then maybe I can further reduce this down from 1429. So the method that I have used is to remove those orders in which there is only one product. So since we are looking at the relationship between among the products, which is basically the purpose of finding the association rule mining, we are looking at the relationship between different products. So if a customer has bought only one product in an order, that we don't have to count that, because it doesn't have impact. At least we should have two products in one order. So the minimum order size in this data set, which means that there are orders in this data set which contains only one product. So we don't need such products or orders. We'll just remove those things, so that I'm interested in knowing only those orders which contains at least two products. So I'm applying those filters, so I'll get only those orders and which contains more than two or more products. So if I apply those that filter, I can consider further reduce it to 1,332 rows. So another 100, almost 100 rows has been reduced from it. So this is a fine-tuned subset uh, which can be used to analyze the data, the association rules. So the next step that we can do is from um, so let's say we have the order ID 2, and we have three products in it. uh, I'm looking at the different product combinations of this. For example, if I consider these three products, that A, B, and C, I'm making three 1:1 combinations of the the products like A and B, A and C, and B and C. So we have received three sets from the order number 2. So, but in order number 3, we have 4 items. So I'll have A, B, C, and D. So I'll have A, B, A, C, A, D, B, C, B, D, and C, D. So I'll have 6 sets from this. So likewise, I have made multiple sets of all possible combinations of the 4 items for all the orders. So now, so this is just this is just a combination of 1:1, but there could be a chance that a combination of a product can impact the purchase of another product. So maybe buying a coffee and milk can impact tend to the purchase of sugar as well. So purchasing two products can also impact the purchase of third product. Third product. So we should not avoid the possibility of a combination of products impacting another product, purchase of another product. So but let me keep a minimum threshold that I'll not go beyond 5 products as a set. So I'll keep a maximum length of 5 products as a set, and then I'll look at the combinations and the rules that it gives. So I've created a dictionary that will contain all possible combinations of one to one to maximum of five sets, and it gives the occurrences of uh, the frequency that the how many times it appears in the total space. So now I have different combinations, and if I divide it by the 499 orders, which is the unique number of orders, like how I did on the individual products, I'll get the frequencies of individual product sets as well here. Now that I'll filter this again, like how I did again above. So I'll keep the minimum frequency to have a minimum 0.01, and so just to minimize the number of the odd number of results. So here, now I have the result, which is actually the product set item sets as with their frequencies, which is the actually when we say frequency, it is actually the support value, like how I explained in my LinkedIn article, the article which I shared on LinkedIn. So this is so now that we have the product sets with their support value, and we have another uh, data frame which has the individual products and their uh, support values. Now I'm going to divide that into individual columns. Like uh, we have two products in it, so I'm just putting that into different columns. So first product will be my A, and second product will be my B. So the set will be A and B. So that so so now I have just divided into different columns, and yeah, and now as I said, I have a two different data frames, one with the individual product and their support values, and the second data frame contains the set and their support values. So now just I'm going to merge these two into one single dictionary, so that I can refer to the support values from one file. So I've just combined these two into one dictionary, so that it will contain the support values of individual products, as well as the support values of the sets. So now, if I just iterate over the dictionary, and I'll get I'll get the support values of A, just referring the product code from the above dictionary. I just made three columns again, which will show the support values of A, support value of B, and the support value of the set as such here. So now that I have made a set, item sets, and the individual products, which is actually the first product will be my antecedent, which is product A. And the second value will be the result. If a customer buys product A, it's a chance that what is the chance that they will also buy B. So now, now that um, yeah. So I have explained the basic behind the formula behind the confidence and a lift. So if I divide support the confidence of sorry the support value of A B divided by support A, I'll get the confidence of A, and the lift will be uh, support of AB divided by the product of A and B. So just apply the formula, and I'll get support of AB divided by A. That will give you confidence. And the lift, the new column lift, is the support of AB divided by the product of A and B. So now that I've received a data frame which contains the similar results that you might get from an a priori algorithm, now I have to filter it further to reduce it further. The only difference here is that from the results of a priori, you will find the item product names here instead of the product code, which I can refer, which I'll do later, because just wanted to keep it clean. I have kept the product codes. So if I divide it, if I filter that with the minimum lift values as 1, and the minimum confidence as lift value as 1 and minimum confidence as 0.02, I'll get only these results. I mean, this is just the first 5 values. So now, as I said, we need to convert this product because we don't know what this product code means. So we need to replace these product codes with the actual product names. So for that, I need to have a dictionary again, and with the product IDs as the keys and the product name as the value. So then I'll just ask the the particular the value for this key. I'll get the product name. So for example, I just made a product, the dictionary with the product ID and product name. Then I'm asking what is the product name of this 12341. So it says I'll get the product name for the code. So just I'll just replace these values from this product from this dictionary. I simply get the value, the codes replaced by its names. So this is the exact file that you might get from any a priori algorithm. That might maybe it might be missing the other the fields such as conviction, but that is not relevant for me. I'm not looking at those things. What I'm interested is only in the support values and the lift and confidence values for this item sets. So now that we have results, which I hope this will be more better results than the, um, the method that we have done that for the maybe the results we might get from considering the add to cart order. That's a method that usually seen on the internet of approaching this issue. I hope this could be a better method, then we might get the more precise answers from applying this method. So now that we have applied successfully on this 5,000 rows, now we have to do the same methods altogether on the entire data set, which contains 32 million rows. So I have this data frame, which contains 32.4 million rows, and I'm going to apply. I have just wrote everything in uh, one one cell so that it looks longer. So it's just the same thing, which we the each step of the codes that we went through, but everything in one place. So it took a longer time, and finally we got the answers without having the kernel breaking. So now that we have results, I can filter. Um, I can sorted it. I can sort it on the descending order of the lift values and the confidence, and I got the results here. And I believe this is a much better result than the conventional method of applying the a priori algorithm on the add to cart values, add to cart field. So yeah, this is my analysis on the Instacart market basket analysis manually, uh, finding the association rules. I hope this might be helpful for at least somebody. If you think I have missed anything, or if I have done any mistake in this, or if something can be improved, please feel free to comment, or please letting me know by message. I'll be happy to correct my mistakes if I have done anything in this, and I'll love to hear your feedback on this on my analysis. Thank you so much.